Hey everybody, today I just wanted to do a quick video on sets in LabVIEW. So let's first find where sets are and we'll talk about what they are. So if you open your functions palette under programming, there is collection. So right next to maps, we have sets. So what a set is this is basically it's very similar to arrays. So it's kind of an array sometimes, but not entirely. So what this is it's an array of elements. So it can be whatever data type. So it could have an array of numbers, of strings, of clusters, of whatever. But it does set a limitation that the values have to be unique. So if I'm maybe having a list of social security numbers, right? Well, there can't be duplicate social security numbers, and the set is actually going to prevent you from inserting duplicate social security numbers. It could be unit serial numbers, it could be employee identification numbers, it could be a whole bunch of stuff. And even, those are very generic things, more test and measurement stuff, right? There's, a lot of applications where we just have unique information and there's not really a scenario where we have duplicates. So this is going to prevent you from inserting duplicates. And another cool thing that it does is it's actually going to order your array for you. Whereas if you have an array, right, there's functions you can use that will then sort it and order it, whereas sets do that for you automatically. So, and we'll take a look at what this looks like. Basically an ordered array of unique values is what a set is. So we have, starting off, let me open context help. So to start out building a set, there's kind of two ways to do that, similar to the maps, like the video I made yesterday, if you want to check it out. But we have basically this build set function, which works virtually the same as the build array function, at least on the developer side. In the background, there is more going on. And then we have set constant. So you can kind of start out either way when you're working with sets. So let's drop a set constant down and you can see what this looks like. So basically this is an array of strings is all it really is, but there's a whole bunch of magic going on in the background to sort it and to remove duplicates and prevent insertion of duplicates. And just like maps, this can be any data type. So I can make it an array of numbers, of complex data types, of strings, of whatever. So that's basically what it is. Build set works the same, basically where I can drag this down and add as many things as I want to it. And by default, it's asking for a string, but it will adapt to whatever data type I pass into it. Just one thing to be aware of is you can't have multiple different data types in your set, just like how an array you cannot have multiple different data types, unless maybe you're using like an array of variants or an array of clusters, and that cluster has different data types in it. But you've defined basically a data type that is a cluster of maybe like a string and a numeric. So the type is defined, and you can't mix and match that. Same with variants. You've defined that it is a variant, although those variants could be represented by different things. We're basically limited to a single data type. So you can start either way. You can have a constant, and you can then build off of that constant. You can have some predefined values, or you can use this build set function. So both of those work great. From there, we have this insert into set function, which basically just lets us pass a value in. So let's just tie into our constant here. Let's delete this build set. So let's say I want to insert a value of 1. And you can see the only output we get out of that is already included. So it just lets us know if that was already included, it's not actually going to be added to the set because it is already in the set. And that's about it. So let's see what this looks like. So I'm going to try to add 1 to my set twice. So let's create an indicator. create a second indicator. I'm not going to fix the names, but you get the idea. So let's run this. So you can see on our first iteration, we added 1, and it wasn't marked as already included. Second time I tried to add 1, it was. So we're not actually able to add 1 a second time because 1 is already part of the set. So it prevents you from adding a whole bunch of duplicates to your set. Let's show a couple other functions. So there also is this remove from set. So I can just pass in a specific element. So in my case, if I wanted to remove 1, I could just drop this down, wire my set in, and tell it to remove 1. And my confirmation here is I get a true or false out for not included. So if it outputs a true, then it was not included, which means nothing was removed from the set. If it was found, it will be removed, and you basically get a false. So that's your confirmation of, hey, was that successful or not? You've got this element of set function, which basically returns whether an element is a member of the set or not. So if I'm curious, I'm like, hey, is 1 in this set? I want to check. Well, I can specify the element that I want to check for, and it's just going to output a true or false. So was it found? We can delete that old one. So here we're just going to add 1, remove 1, and then check if 1 is found. So let's run this, see what that looks like, and it's false. So we added it, but then we removed it. So when we checked, it no longer was present. So that's really all it is to look for specific items in your set. Really, really simple. Let's scoot this back. So yeah, you've got your set max and min. So basically, hey, I want to know what the max and min of my set is. This will do that for you. Similar to like array max and min, just for sets. There is collection size, which basically allows me to read how many elements are in my set. So, initially, if I did this right here, we have 0. Once I've added an item, I would have 1. Then I removed it, so I'm back down to 0. So if you were curious, similar to the array size function when working with arrays, just how many elements are in here. There also is this empty collection function, which just returns a true or false whether you have an empty collection or not. So if I did this right here, it would return a true. If I did this right here, it would return a false. The other thing you can do is you can convert your set to an array. So here we have our set. Maybe I want to get all of the values out of my set. So I don't want to just, get a specific thing. I want to get everything out of it. Well, I can just drop this bit of code down, and really all it is a for loop that just uses auto indexing to get each individual element and then auto index it on the other side. So dragging this from the palettes, it just saves you a little bit of time. It's not anything that you couldn't create yourself. And then I now have just a regular, I can create an indicator so you can see I just have a regular array. So we've converted this set to an array. And yeah, it's just going to output all of the values that are in there. So I may need to, have some code that, acts on this set and does certain things. Well, there you go. So yeah, let's add a value of 5. Let's run this. And we get 2 elements, 1 and 5, just like you'd expect. So I inserted a 1 and a 5. So yeah, that's kind of the core functionality of sets. So there are these other functions down here we have as well. So set union. So this is used when we're working on basically multiple sets. So I can set the union. This is going to basically compute the union of 2 sets. So basically finding matching elements in the 2. So if I have 2 different sets and I want to say, hey, what's common between these? This is how you do that. So intersection, similar, Cartesian product, set difference, and symmetric difference. So these are ways that you can basically compare two separate sets and get things that are different or the same or whatnot. I really never use these. Most of what I do is just handled in these kind of top functions right here. But they definitely have an application. So yeah, if you find yourself working with multiple sets and you need to be able to do some comparisons between the sets, these are what you're going to want to do. But yeah, that is basically what a set is in LabVIEW. Hope that was helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.